Hello, Algebra. Mr. Garrick here. So we are kind of taking a turn from the properties that we just got done with and moving into exponential functions. So people look at this lesson and think, oh crap, word problems. But after doing a few of them, I hope, and it has happened in the past, where it's actually not that bad of a lesson. People usually do pretty well with this. So identify and explain the various parts of an exponential function, which is what we're going to start with, and then write and evaluate an exponential function, which is the word problems. So an exponential function has a general form of y equals a times b to the x. Now looks like there's four variables there, but not really. There's actually only two variables, x and y. Okay. First thing I want you to see is where the x is at. It is an exponent. That right there is what makes this an exponential function. Okay, the exponent of x makes it an exponential function. So if x and y are my variables, what are a and b? Well, a is the initial value or the starting value. Okay, this value can never equal 0. If it equaled 0, we wouldn't have a problem here because 0 times anything would be 0 and we wouldn't have anything. Okay, so that's A. B then is the tricky part, but B is the growth or decay factor. And if you look back at the title of the notes, you see that that's where we're going, growth and decay. All right, so which one is it? And how do you know? Well, if B is bigger than 1, then the function is a growth function, which means it just gets bigger over time. Okay. If B is between 0 and 1, then the function is a decay function, which means it gets smaller over time. Okay. Notice the inequality here. It's a compound inequality. B is between 0 and 1, and it can't be equal to 0, and it can't be equal to 1. All right, so it's between 0 and 1. So that's the parts of your your exponential function. X and y are the variables. A is the initial value. B is the growth or decay factor, depending on what B is in the problem. Okay, now let's look at some examples. Identify the initial value and then determine if it represents growth or decay. All right, so first one, the initial value is 12. Is this growth or decay? And how do you know? This one's actually growth because B equals 1.05, which means it's bigger than 1. Okay, anything bigger than 1, even if it's just a little bit bigger than 1, is a growth function. Okay, on number 2, the initial value is 0.4. This one's also growth because B equals 2, and 2 is bigger than 1. All right, so B is bigger than 1. Last thing, number 3, or last example, number 3, the initial value is 5,000. This one is decay because B equals 2/3, and 2/3 is less than 1. It's bigger than 0, so one thing I do want to point out, actually two things, before I move on to the actual word problems. People think that if there's a fraction, it's decay. That's not always the case. I'm going to clear that real quick. Let's say that this was a 4 up here. 4/3 is a fraction, but that fraction is actually bigger than 1. 4/3 is 1.3 repeating. That would be a growth function. Okay, so just because it's a fraction does not make it decay. Make sure you make that clear. Second thing is, I didn't say this up here, I should have said it. B can't be negative. We got a different animal when B is negative. So B can't be negative. I kind of said that in the inequality, but just want to make sure you understand B cannot be negative. All right, let's go on to the word problem. The population of a city is 50,000 and it increases by 3% each year. Right, and in exponential functions represent this situation and then tell how many people live in this city after 5 years. All right, so I have A equals and B equals. Before I talk about that, I want you to see this part right here. Once you find the values of A and B, you can write the function. The A value is typically given, but the B value takes a little work. So the A value is the starting population in this case. So the A value here is 50,000. That one is usually pretty easy to identify. The B value, again, like I said, takes a little work. I'll come back to this blank up here. The growth rate is 3% each year. So the 3% as a decimal is 0.03. So that's the growth rate. The growth rate is 0.03. But try using 0.303 as your B value. Why is this incorrect? Well, again, this is wrong. Don't do this, but I'm going to show you 50,000. Let's say I said B was 0.03. Well, do you see how that's less than 1? This would be a decay function if I use that as my B value. This isn't decaying, it's increasing. So this is a growth function. So what do? This is bad. I don't like that. What do? To find the B value, you take the percentage or the growth rate, which is this is R, and either add it or subtract it from 1. Okay, now which one do you do? If it's growth, you add it to 1. So 1 plus R. If it's decay, it's 1 minus R. Okay. So we know that this one's growth, right? Because the population is increasing. So to find B, I'm using this formula. So I know I have the back. You want to flip over to the back, but I have it showing here. In the previous example, or in this example here, we got 50,000 as A. And B is going to be 1 plus 0.03. So that's going to be 1.03. With those two things, I now have enough to write the function. So it's y equals 50,000 times 1.03 to the x value, to the x exponent. Now, before I move on, you have to understand what x and y stand for in this problem. X is going to be the number of years, and y is the population. Okay, so we're looking for the population after 5 years. 5 years is an x value. So plug it into the formula, you get y equals 50,000 times 1.03 to the 5th power. Now, in your calculator, you have to know how to type this, okay? I like to do 1.03, and then there's a button that looks like an arrow pointing up. It's right above x squared on the left-hand side of your calculator for most of you. And I hit that button and then hit 5. And when you hit enter, you should get like 1.159274074. Okay, that's just this part of the equation. Now I need to take that number and times it by 50,000. So I'm just gonna, without clearing anything, I'm just gonna hit times 50,000. And I get 5796. I'm gonna change colors here so you can see it better. I get 57963.7. Now this is, you can't have 0.7 people, so we would want to round this to the nearest whole number. So 57,964 is what we would write. Would be the population. Okay, that's after 5 years. Okay, next example, a new car costing $20,000 depreciates in value 16% each year. Write an exponential function to represent the situation and then find the value of the car after 7 years. So first thing you have to understand is what depreciate means. Depreciate means goes down in value. So this is going to be a decay. Okay, the A value is the starting value, so 20,000. Like I said, pretty easy to identify. The B value is a little trickier. sure why that's not working. Try that again. So with it being decay, it's 1 minus R. The rate is 16%, right? So R equals 16%, which is 0.16. Okay, a lot of people will take 0.16 and put it in. They'll say 20,000 times 0.16 to the X. Don't do that. That's not B, that's just the rate, 16%. What you need to do, let me get rid of all that I just wrote, is take that, put it here, 1 minus 0.16 is 0.84. Decay is a little tricky because 84%, you don't see that in the problem anywhere. 84% was not in the word problem at all. You had to come up with that by doing 1 minus 16%. So there's my B. I already got A. My function is y equals 20,000 times 0.84 to the X. The value after 7 years is just putting 7 in for X. And so I do 0.84 to the 7th power. I get, if you're doing this with me on the calculator, you get 0.295090347. Then I'm not going to clear anything. I'm just going to hit times 20,000. And I get 5,901.806. And I stop there because this is money, right? Y is the value. It's a money thing. Money always goes to 2 decimal places. So I'm going to look at the 6 and determine what this is going to be. 6 is closer to 10, so it's going to be 81 cents. And that's my final answer here. All right. Okay, a new type of question. This is asking you to interpret and make a conclusion based on this information. So after 15 years, the buyer decides to sell the car for $3,000. Is this a fair price? And explain. Well, what we need to do is we need to figure out how much it should be worth after 15 years. So I'm going to take 15, plug it in for X. So I'm going to get Y equals 20,000 times 0.84 times 15 to the 15th power here. Let's go ahead and type that in the calculator. What do you get? I get $1,462.92. That's what it's worth at 15 years. Okay. If he's trying to sell it for $3,000, is that fair? Well, probably not. So the answer to this question, is this a fair price? Is probably not. Why? He's asking double what it's worth. Now, it's not really double, right? You know that it's not exactly double, but it's about double. 1462 is really close to 1500. Is asking a little bit more than double what it's worth. Now, I understand if you are a car person or whatever, and you're like, hey, that's in really good shape. Maybe he took really good care of it. That's a different story, but we don't know that. We don't know what condition the car is in. We just know it's a 15-year-old car that depreciated in value 16%. So we would make that conclusion with the information that we have. Okay. Last one, a little bit tricky. If you've ever seen the movie Pay It Forward, it's an old movie. An idea is brought about by a boy who wants to make a difference in the world. The concept he comes up with is to do one unexpected nice thing for 3 people. And then each of those 3 people is to pay it forward by doing something nice for 3 more people, and so on. Write an exponential function to represent this situation. Okay, so A is not as easy to come up with on this one, but the idea starts, the initial starts with 1 person. So A is actually 1 here. B is basically what's happening is 1 person is doing 3 nice things for 3 people. Or sorry, 1 nice thing for 3 different people. So each time this occurs, the number of people it affects triples. Tripling is kind of hard to explain with the 1 plus R idea. But when you have a triple, the B value is 3. All right, just go with me on that. B equals 3. If it was doubled, it would be B equals 2. So there's my 2. So my function is y equals 1 times 3 to the x. If this happens 5 times, so if this whole phenomenon occurs 5 times, how many people are affected? X is the number of times it happens. So it's going to be 1 times 3 to the 5th. So 3 to the 5th is 243 times 1 is just 243. How about 10 times? Well, instead of 5, I'm going to put 10 there. So then 3 to the 10th, you get a much, much bigger number. 59,049. What happens if it happens 50 times? Okay, 3 to the 50th power, huge number. Doesn't even fit on your calculator, not even close. All right, so it's 7, and there's a lot of decimal points. So I'm just going to round to the nearest 10th. So I'm going to say 7.2. Or 7.17. So I'm going to do 7.2 times 10 to the 23rd people. So that's a lot of zeros, 22 zeros. That's a number I don't even know how to pronounce. Okay, so if this occurs 50 times, literally everyone on Earth would be affected. Okay, so you can see how quickly this grows. All right. You're going to see that more when we graph it in the next lesson. But for now, that's the end of this lesson, and that's it for this video.